for the state of Utah, and I want to talk to you a little bit about some of the research that we've been working on over the last 10 or so years, and bring you up to date on a few projects that have some interest in this particular area. And then a little later, after my presentation, Jennifer is going to come in and talk about some of our fruit-related research. So essentially, when we're looking at the focus of these projects, it's to kind of create more sustainable farms for Utah, and primarily addressing questions that relate to weed management options in asparagus, one of our perennial vegetables that some of our growers are using and finding a good market for. We're going to talk then about a second project that looks at cover crops and vegetable crops and looking at potential rotations that fit into an organic system. And then our third one is going to be talking a little bit about a project that Jennifer and I did that looks at compost carryover in irrigated vegetables, particularly in intensively managed environments, and some of the issues that are associated with that. So these will just be kind of a quick snapshot of those things. For the asparagus work that we've been doing, if anyone that knows me knows that that's one of the plants that I like to work with. I've been working with asparagus now for about 35 years, and I was looking at opportunities for it, some organic related production on asparagus, and essentially what we came up with was, one of our big problems is going to be weed management in these perennial systems, because as soon as we get a perennial crop that is growing close to the ground, comes up in the spring, and you deal with perennial weeds, it's how do you kind of come up and manage those things. So we came up with kind of a standard approach of trying to till the soil, and you can see on the left side there that in that system it did a reasonably good job of managing and controlling the weeds, particularly during the harvest period. We also had a grass treatment where we tried to use a bunch type grass in between the planted rows in an attempt to try and at least create some weed management that way. But we had some contamination with clover, and the clover spread, and everything kind of got out of hand kind of quick. But we could mow it, and that was okay. We could get down and do that and kind of work with it reasonably well. We tried some flame weeding as well and ran into some funny issues with it in that all the residue from the asparagus, which we mowed and kind of laid on the surface, tended to catch fire, and we were afraid we were going to burn up the countryside. So we kind of thought that this isn't a very good approach in one of these systems. And then we had this straw mulch system, which looks really well there when you see it. This would be probably around the fourth or fifth year. This is kind of on the margin there, but you can see that it did a reasonably good job, and that was putting down about 6 inches of straw right after the end of the harvest season and then leaving that in place. So those were our approaches. The key thing that we need to think about when we're thinking about asparagus growth is certainly focusing our attention on what's happening during the spear growing period, and most of our energy during that time is coming from the root system. And so growing yield is going to be tied with how big your root system is in an asparagus plant. And so we're going to kind of take energy from that orange section and feed it up into those spears to grow them, and that's what we really want. And then we have to retain enough energy in the root system to grow the canopy or the fern so that we can fill the root system again during the summer months. And as you're thinking about weed management, you're concerned about season-long, really, weed management, because weeds in the springtime interfere with the harvest period. It makes it difficult to find the asparagus spears in some of those treatments, so that's annoying. And then if we have too much weed growth during the summer, then there's just this competition that's going on. And fern, interestingly enough, gets fairly big and is very dense, so it can do an effective job of shading it out, the weeds out underneath it. So there may be strategies that these things will work well for us. And so what we're trying to do, this work came from some work that I did way back in the early 90s, where we were looking at the differences between a tilled system and a non-tilled system that incorporated herbicides into the program. And so the non-tilled ones had a herbicide applied underneath it, but you could see the difference that occurs in root growth as a result of these. So the tilled ones, we had substantially smaller roots, and interestingly enough, asparagus roots are very deep in the soil, but a little bit of surface tillage can do an awful lot to changing how that growth dynamic occurs. And so the goal, particularly during the early establishment years, during the first 5 years after you plant an asparagus field, is to try and just maximize the total amount of root biomass, because that's going to be directly correlated with how much productivity you're going to get. And yet, if I'm doing, or we're trying to do all of these treatments to manage weeds at the same time, we may be interfering with the ability, our ability to grow a big root system. Okay, so it's kind of like our example this morning. We want to have large trunk diameter, a big tree, because then we know we've got a lot of potential fruiting sites, and that's going to give us high fruit yield. Okay, so it's kind of in reverse on this plant, but it's the same concept. And so we got to balance those types of things. And working with many of our large commercial farms around, they do a tremendous amount of tillage work to incorporate residue for disease management purposes, for insect management purposes, and certainly for weed management purposes. And it's how aggressive a grower gets that dictates how well this crop is going to perform. And so many farmers, asparagus farmers in particular, have gone to somewhat of a no-tillage based system in an attempt to try and maximize root growth, but in the long term, the perennial weed problem starts to creep in. And we kind of tried to simulate that in our trial, in that we selected a site that had a very high perennial weed population, so we put it in a stressful environment, and then we put in grasses or clovers as an attempt to also even create more pressure that's perennial in nature, and then look at the impact of those things. And ultimately what we want is lots of spears of the appropriate size to meet our market requirements. So we planted this field in 2007 using a variety that is commonly used here in the state. Lots of weeds in the thing, and then we did this tillage system where just before harvest we would go in and till maybe to an inch deep or so over top of the whole plot, and then we would harvest, and then we would do that again at the end, and that was the bulk of our weed control. The grass legume mulch was mowed, and it would be mowed in the early spring and then mowed toward the end of harvest, and then possibly once or twice more during the summer months. The flame weeding was designed more for pre and post effects, and the big problem pre was if the fern that we were mowing off was pretty dry, we had a fire hazard. And so that one wasn't the best in this type of system. You know, it's not like we heard Tim say, we got bare ground, we got some new fresh weeds growing, you got soil and weeds and nothing else there, you know, burn away. You're not going to start anything on fire. This one, we had some cases where we had some problems, so we didn't want that. And the straw mulch one, you know, was by far the easiest kind of to work with, because we would just at the end of the harvest period put out our mulch, put a thick layer of it out there, and then work from there. And then we ran harvests from 2009, really. We had a short harvest in 2009, but I'm going to just show you some information from 2010 through 2012. And we kind of broke this down into early production, early production would be like the first 3 weeks of our growing season, and we can see that we had some separation where the stars are. We can always see that grass treatment where we did our mowing one, that's basically our mowed treatment. We tended to do fairly well, and then the straw treatment also did quite well, and both the flame one and the till one kind of quite a bit less, though not always different. And our yields early were pretty good, so, you know, because we want early production. So we didn't really see any delay in production. And one might say, well, we're getting a delay with the tilled ones, but it was more just that the treatment wasn't that effective. And early is key for us, and that grass one seems to be okay, even though there seemed like there was a lot of competition. When we went to our full season production, once again, what we saw was that grass treatment kind of stood out along with the straw treatment. In some cases, our flaming treatment was better or worse, and oftentimes the tilled one varied a little bit. And the lower levels of productivity that we see are somewhat seasonally dependent on what the environmental conditions are like. So ultimately, I'd say that while we didn't get the best set of weed control always with our grass treatment, we just had pretty much a grass-clover mix. We didn't have a lot of other weeds in that system, and just by mowing it a couple times during the year, we were quite easily kind of maintaining the system. One of the other sets of data that we collected that we're still looking at is we've got a whole bunch of irrigation-related water, soil water type data, and we're going to be looking at that, and hopefully by midsummer or so I should have that finalized in this whole report, and then we'll put that up on our website, at our horticulture production website at the university. So essentially with weeds, we're kind of looking at, you know, we need to control both annuals and perennials, but we were focusing most of our attention on some of the perennial problems. We didn't see a lot of annual weed problems, though prickly lettuce was one of those that did kind of show up. Mowing seems to be a pretty good method of doing it. Straw was pretty good as well, but we did see some slug issues with straw. That was probably one of the problems that we kind of ran into, because that mulch was fairly thick and it was a nice moist environment for those slugs to take into place. Flaming, I probably wouldn't recommend that one, just simply because I'm afraid of the fire hazards that you might get, and then the pre and post did our best weed management kind of when we came right down to looking at it. But we always saw a suppression in productivity, so it's kind of like one of those things that, yeah, we're going to get better weed management, but I'm losing productivity, and many of our asparagus growers are getting $2 or $2.50 to $3 a pound for asparagus, so, you know, any major reduction in productivity is just dollars out of your pocket, and so you need to think of those kinds of things. It was a fescue, a bunching fescue, and clover. Yeah, we mowed it to, you know, two inches or something like that. Maybe 3 or 4. And it kind of depended on how vigorous it was. Okay, the second series of work that I want to talk to you is about this long-term cover crop vegetable rotation, where we're interested in looking at productivity of the vegetables. We're looking at changes in soil quality, weed dynamics, and we're focusing our attention on 3 winter cover crops and 3 summer cover crop combinations. So essentially 9 different interrelated cover crops. And then we've got 3 associated vegetables that we're growing with them. And the cover cropping systems that we're focusing our attention on are a grass, a broadleaf, and a legume in the winter months, and a grass, a broadleaf, and a legume in the summer. And then our vegetable crops are also a grass, a broadleaf, and a legume. Okay, and then we're going to pay attention to nutrient cycling in a system that gets no additional fertility. So we're not putting compost down or manures or anything like this. We're looking at, you know, strict nutrient cycling through the use of cover crops and the various combinations. So essentially the plants are there, the cover crops are there to stabilize the soil, to suppress weeds, try and trap the nutrients that we have in the system, to look at the microbial activity and the nutrient cycling associated with it. And then we've got these various combinations that are being used to try and manage the systems. So let's look a minute at the different crops that we're dealing with. So our legume in the winter is going to be hairy vetch. That's going to be planted in September. Winter wheat, which is our grass, that would be also planted in mid to late September. And then we're using, as a broadleaf, we were trying mustards for a while. We've tried some radish, so a brassica as a broadleaf, and we probably had our best success with kale, just for establishment and overwintering capabilities. And then our summer cover crops are either beans or vetches as a summer cover crop, so another type of legume. We've got proso millet as our grass, and then we have buckwheat as our broadleaf. And those would be planted in June with an August incorporation, and that then tends to be rotated between what we're going to do with our various vegetables. No, they're individually planted, and so that's what I'm going to explain here. So if we look at our cover crops for our summer, we're going to basically have individual cover crops, not combinations of them, but individuals that will create all of these different combinations, so that what we have is some plots that will be every year we'll have legume combinations to them, so we're going to try and fix lots of nitrogen in that system. Other ones that are always going to have broadleafs. Okay? And so these unique combinations are designed to explore how the different cover crops impact nutrients and impact weeds, and ultimately impact the vegetables that we're interested in, because that's what we're really interested in. So if we look at the way we've done these plots, you can kind of think of them running at angles to each other. So if we read across this top diagram that we have, the top line would be like out here is going to be our hairy vetch on the one side. The next section underneath it is going to be wheat. And in this year we use some rape, but we could also use some other type of broadleaf. So that would be our broadleaf weed. And those would be our winter crops coming across this direction. And then up and down in the summer, we're going to grow either buckwheat, or we're going to grow the millet, or we're going to grow some other type of legume. Some years we've used a vetch, some years we've used another type of bean. So you can see, if you look at the bottom, or the pictures in the middle, you can see kind of the effect of this particular year where we had mustard, wheat, and vetch. You can see how the three vegetables that we're interested in, which are a legume, which would be our beans, our broadleaf is our broccoli, and our grass type plant is our sweet corn. Okay, so we're having always in these areas, and we're looking at the effects of how those are rotated within each other on productivity, and on weed management, and on soil characteristics, and on nutrient cycling. And we've got lots of data, and I'm only going to show you a very small smidgen of it right today. And ultimately what we're trying to do is understand the effects of that. So here's an example of where we had, on the one side, you can see in the foreground where we have millet as our summer cover crop, and we can see how much millet growth we got on the left side when we had hairy vetch growing prior to it. In the middle, where we're growing two types of grasses on top of each other, so the strip through the middle here, this would have been all wheat from here all the way through. This section would have been mustards. This section from here would be hairy vetch in the winter time. And then in the summer cover crop, looking at it, we can see the growth of our vegetables in the background. Look at how our broccoli is after the hairy vetch, how nice and green and vigorous it is. Look at how poorly the broccoli grows where we had grass after grass. And and kind of intermediate where we're growing the broccoli where the millet and mustard combination is. So essentially we're trying to figure out if these things do different things for us, which we know they will, and at the same time, are we able to get sufficient productivity out of the desired vegetable crop that we want? So let's look really closely at some of these combinations just so that you can get a sense of them. Here on the top one, in the winter we always grew mustard, and now we're looking at the summer cover crop. So on the one side we had growing some black beans as our summer cover crop, which were drilled in there with on a very tight spacing in order to get biomass. We can see how much millet growth we had, or we can see what kind of buckwheat growth we had. Now let's look at wheat as our crop with those various combinations and explore a little bit. In a minute I'm going to bring them all up so that you can kind of compare them all together. And then if we look at that where the vetch is, then we can start to see the variability in even the amount of biomass that we're growing. If we look at the center section there where we're growing millet in the summer, we get poor millet growth where we have wheat as a prior crop. We get better millet growth where we're growing after mustard, and we get the best growth after that legume, which we would imagine. And the same thing holds for all of these crops, and that then becomes a way for us to build fertility in this soil mix. And in the spring then, what we would do is we'd come in, we can see here the person in the front, he's planting some broccoli plants in these plots, and you can see how much vetch growth we have. And in the back where the person in the red coat is, she's planting it in the wheat section, and beyond that, a little bit farther back is the section where the mustard or the rape or one of our broadleafs, in the case of recently using kale, becomes our winter cover crop, is being put in it. And then we're going to track the level of productivity under these various regimes. Now let's kind of look at the impact of all of those things on one crop. Here's just visually looking at the weed complex, looking at the amount of plant growth that we get. Each one of those images has about 4 plants in the photo, so you're kind of comparing the same thing to each other. And notice the broccoli growth that we get, how much growth we get, particularly where we had the vetch treatment, the hairy vetch treatments, which would be the bottom section there, and then growing. Really not a lot of difference, though there is a little bit more growth in that far over one where we have the hairy vetch and the chickling vetch, which we used as our winter cover crop and our summer cover crop. Bigger heads of broccoli, more vigorous plants, better plant cover, fewer weeds in the system, and where we had things like in the top row where we had the mustards, which were closely related to our broccoli, how that suppresses the growth of those particular plants. And then particularly notice where we have the wheat. Plant vigor is greatly reduced, even if we have a legume put into that system, so that the biomass, the residue, and the lack of nutrient cycling really has a big impact on how well these plants perform. And if we look at productivity, essentially this is a measure of the weight of the broccoli heads per plant over a 3-year time frame, and effectively the little coatings that are there would be our winter cover crop followed by our summer cover crop. And essentially we can see in our visually we saw it in our pictures that the wheat ones and those bars that are in the middle of the graphic there show that our lower yields are where we follow this crop after wheat in it, and it really doesn't matter what summer crop I have. And if we look at the hairy vetch ones, which are the ones closest to the right side of that, all the time where we have that extra nitrogen, which we know broccoli is a high-end using plant, we get the highest level of productivity. And then there's, the mustard one, which, kind of goes up and down and all around, and it doesn't really follow any distinct pattern per se, and it's not real clear yet, if there are distinct combinations that we should use. But obviously, these plants need a lot of nitrogen, and most of these on the left-hand side, where our winter crops are either a brassica-related crop, similar to our broccoli, tends to somewhat suppress that productivity. Okay, so we can see that. If we look at some of the other crops that we were growing, we've had a lot of struggle with sweet corn in the system. Organic sweet corn seed is not very vigorous for some reason, and certainly when we put it into an environment where we have a lot of residue, a lot of microbial activity, we find that there's a tremendous amount of problems with getting adequate stand establishment. So I'm not going to really talk about sweet corn too much because we struggled with that one. If we look at beans in the rotation, we would think, well, here we have another nitrogen source that could get in, and when we pull up our bean plants, lots of nodules on them, so we're fixing lots of nitrogen in these situations. It's a little not nearly as clear, but certainly it kind of looks like when we follow certainly the wheat treatments, some of the wheat treatments, particularly these two where we have wheat and the proso millet, which is the one PM one, or wheat and buckwheat, that tends to somewhat suppress bean yields, even though we seem to in those get fairly good weed management in it. Those are good combinations for weeds, but they're suppressive to the growth of it. And then if we look at the wheat and the chickling vetch, so our summer nitrogen source, tends to be pretty helpful to it, so that WHCV one seems to be a real good one, as well as some of our mustard treatments where we're either following a grass after that mustard or following buckwheat after that mustard. So the beans overall a little bit more stable in their levels, and so certainly as we start getting more and more of this data pulled together, there seems to be different nutrient levels that we're able to sustain in this soil just through these rotations without any additional fertilizer being added into the system. So that's just using the cover crops. So the crops tend to respond differently. Productivity is not as high as if we could supply some additional nutrients. We know that our yields are kind of on the low side, but we're seeing whether we can just manage things that way. We're getting some good weed management approaches with this, and we are doing some cultivations and things like that in it, but we're doing the cover crops themselves are doing a good job of managing in some of the treatments. And certainly, we've just now gotten through the first rotational cycle for our vegetables. So in our plots, we would have our summer cover crop from this past year, and now our vegetables are going to be grown in that. And then the place where the vegetables were grown this year is where our summer cover crops are going to be. So we've just gotten through that first cycle, and now we're starting our second go-around on it. And so we should have better information as we move forward. Now, the final project that I want to talk to you about is some of the work that we've done with season extension technologies, where we're using high tunnels to grow a variety of vegetables. And we're basically, for a while, we took an approach where we were going to focus on organic approaches. And essentially, the objectives were to improve our early or late season production of these crops, and then to compare an organic approach to a conventional approach primarily with a focus on nitrogen, okay? And then to better understand what happens in these intensively managed systems where it's very easy for us to do nearly year-round levels of production. We essentially took composted poultry manure and applied different amounts of it to supply a total amount of nitrogen of either 100, 150, or 200 pounds of N to the acre, and compared that to sites that had conventional urea nitrogen applied at those same rates. Now, certainly with manure, the release factor of that is going to be very different. So we basically just took the sample, analyzed it, and said there was this much nitrogen in it, but exactly how much of that nitrogen became available immediately is going to be very different between these two systems, okay? And then thinking about that over a number of years where these same treatments got applied to the same plots in the research for many, many years. In our tunnels then, so we would spread out our compost for our various treatments, incorporate those with a small tractor in the tunnel, and then lay plastic drip, put row covers over top of them, transplant tomatoes roughly around the 1st of April, up in Logan, and then look at our level of productivity. So in our tomato systems, so this would be on the left-hand side, you know, in early to mid-April. By the early to mid-May, we had large tomato plants growing. By mid-June, we had large plants that were heavily fruiting, and then we would start usually harvesting tomatoes out of our tunnels around between the 1st and the 10th of July. And so we looked at the effect of this continual addition of these nutrients, particularly the compost we were interested in, on the impact on fruit size and total fruit productivity. And what we can see in the first year that we did this in this highly managed system, we had significantly lower levels of productivity from our tomato plants that were grown in an organic system. Okay, so we had to charge this system up, and it's going to take us some time. And you can see that we were reduced in the number of large size fruits, the medium size fruits, the weight of the small fruits, and then the number twos that we had, which was a kind of a combined, we didn't really separate those out in that first year. So in all fruits classes that we were interested in, major reductions in productivity. In the second year, we had a little bit of continual carryover. Our levels were a little bit lower in our number 1 large fruits. They were a little higher in our number 2 small fruits, but effectively by the end of the season, there was no difference in our productivity, and our productivity levels between the conventional from 2006 and 2007 are comparable. So there really wasn't any difference in yield from one year to the next. And then when we went and looked at 2008, once again, we saw that there was no impact. So it didn't take us very long in a highly managed environment like a high tunnel to quickly build up the level of productivity. So the question was, what was going on in these systems? And we went in and we looked at, after 3 years of this continual application of compost to these systems, what was happening to nitrate nitrogen, ammonium nitrogen, phosphorus, potassium, pH, and all of the few other characteristics. And essentially what we saw in our system was that when it came to nitrate nitrogen, in our conventional system, we had a lot more fertilizer and residual in that top surface of the soil when we keep adding urea into the system. And we would imagine that. I mean, we were just adding it in, and we got high levels of it, and a lot of that's flowing through the system, because if we look at the 6 to 12 inch depth zone on our conventional fertilizer, we can see that the levels are quite high there, and on our organic fertilizer, they're, you know, quite a bit lower than that. Ammonia nitrogen is somewhat comparable between the two systems and between the two depths, but they aren't different from each other. But notice what's going on with phosphorus. So we're using poultry manure as our that's what the initial compost is being formed from. We're getting extremely high phosphorus levels, that 136 versus 39, where we're kind of applying it, conventional fertilizer into the system. And then in our deeper depths, even where we're getting 6 to 12 inches in the bed, we're even elevating that level. Look what's happening to our potassium. So, you know, we're kind of thinking, well, I'm only interested in the nitrogen, but there's all of these other things that are tied into that fertilizer. And if we just indiscriminately add it and say to ourselves, well, I can manage it, the plant's using a lot of it, I need that fertilizer there, I'm just going to apply this compost. So the memory of, you know, this bark that we put underneath this tree and these apple orchards and how quickly that changes the dynamics, these things can change even faster when we're doing that. So, you know, start to think about what's going on. If you've got a tunnel and you're kind of putting compost into this thing, it's going to quickly get out of hand, and we've got way excess amounts of phosphorus and potassium in that compost-based system. That is getting to the danger level for other imbalances that might occur in these plants. Question? Well, you're right, and that's really where the next step for the research has to go. You know, how quickly can we get the level up to be able to support high levels of productivity, because that's what we're trying to accomplish, and yet at the same time not create this other problem for ourselves. So that's the next thing. So maybe our goal should have been to say, well, I need additional nitrogen in this system for my tomatoes. I know that I can't grow high levels of tomato production without having at least 175, maybe 200 units of nitrogen. So I need that amount, but I need to find it from a different source that doesn't supply the phosphorus and doesn't supply the potash and some of those other kinds of things. Question here first. That's a possibility, yeah. Yeah, or that might do the job for us, you know, if it's not too competitive or whatever, or to be able to say, well, what kind of organically based N source can I find, let's say alfalfa or something like that, which it would have a high N level in that material, but a relatively low level of P and K. That would be a way for us. So you're thinking along the right lines. What we're trying to show you is that, you know, we just do this. A recent report out of the Midwest showed that, you know, if you went and evaluated farmers that are doing things organically, their approach is, well, compost is a fertilizer, I just apply compost. And I just do this, and I don't really test enough my system to see when I'm getting up to levels of maybe potentially problematic levels of some other element. And we know that there's this N to K ratio that we need to get high quality tomatoes. And one of the things that we started to see in the later years of doing these things was that we started to get some imbalance that shows up as, you know, green shoulder or so in the tomato fruits that is tied with a too high of a K level, not high enough N level, even though the levels look pretty good here. No, I know it doesn't solve those problems, and that's something that Jennifer and I are talking about. And yeah, a legume cover crop. So coming back to our hairy vetch again says that's what you need to do. If you take that information, you need to be planting that in the fall. That gives you your nitrogen. You've got the P and K under control. You're actually trying to figure out a way to bring it back down. And certainly, you know, that becomes important for us. Then what we did with these ones is we came back in afterwards and we didn't apply any additional compost in the fall, and we just grew a range of different kind of fall-grown greens, things like lettuce, pak choi, spinach, that we would put in these plots. Note how well our organic treatments did after that. You know, there's plenty of nutrients left in there. You don't need to be applying more fertilizer if you've been applying compost to them, and use those resources to try and mine it out. Take the advantage of that winter production when there's a demand for some of these winter greens, and still get really, really high levels of productivity out of them. I mean, the organic ones were well above the conventional ones, and so it kind of it reinforces to you guys to be thinking about what we need to be doing. So in conclusion then, the last thing we'll say here, and then we have a few minutes for some additional questions, is, you know, with these perennial crops like asparagus, when you're dealing with them, and I think we heard it with our fruit crops too today, we're looking at, you know, the weed issues in those crops are unique. And I think that message, if you didn't catch that today, you know, kind of think about it now. Tim talked about it. Amaya talked about it. Lori talked about it. We all kind of focused in on some of those things. This cover crop stuff, we're still working our way through that, but it's very much crop specific, so we're going to have to focus a little bit more attention on that. But that project is going to go on for, you know, at least another 3 to 5 years, and maybe longer than that. We've got these plots established. We don't want to lose them now because we want the long-term work like we've seen in the Cornell project and the trees. And then the final things is lots of you are going to tunnels to do things. You know, it's really a good system. It's worked really well for us, but run a few soil tests. Kind of look at what's happening in those things, and then if there's questions, let's talk so that we can try and mitigate some of those excessively high levels of other elements and focus in on what's really critical to you. We can do that. We can tailor these things. And Dave is absolutely right. You know, it's, you know, you almost have a heart attack when you think about buying nitrogen, organic nitrogen fertilizer. It's off the charts. But there are other things that we can do that we can grow ourselves. And we know some covers that will grow really well here and put a lot of nitrogen back into the system. So with that, then I'll take any additional questions. Well, good. You're tired. I know. We're all tired in the back. Jennifer does some early spring sowing of hairy vetch, don't you, at the student farm? Don't we do any of that? All fall done, yeah. And it actually is better the earlier you can get it in. That's what we found. We've kind of initially, when we first started, we were planting late September. This is in Davis County. We're doing it at the Kaysville farm, this trial. Planting in late September, and we don't get enough establishment. If we can plant it a little earlier than that, let's say early September, that's when we get about that much growth in the fall, and then as soon as the snow goes off, it just explodes. And we get huge amounts of production of biomass by mid to late April, which is kind of, we were trying to plant our broccoli right around the last of April is what our goal was. Yeah, we mow it about 10 days before, mow it, and then rotivate it in. Yep, so it's incorporated. Yeah, as deep as we can get it in, and probably 10 days. One of the things that we've decided too is that you don't get enough breakdown early on, and so it would be nice if we had a little longer time to let it decompose before we came back with our crop. And I think that's part of our problem with our corn is that there's just so much, you know, microbial breakdown that's going on. You put that corn in there and it's got a lot of sugar in it, and those microbes just hit it. And when we dig up those young little corn seedlings, you know, they're just covered with mycelia, so the organisms in the soil are acting on it as well, impacting the establishment of it. Question here. Mowing it and then you just let it sit there for 2 weeks? No. We're mowing it and then immediately incorporating it so that the soil can start to break it down so it can release the nutrients that are in it, and then we can... Well, or it becomes hay and it just lays on the surface like hay, you know, and hay the nutrient doesn't go very far. It dries out really fast here, as you know. And so the quicker we can get it in, the more likely it's going to break down. I think one more question. Yeah, go ahead, Joe. No, and I know, and what we've been trying to do is to say, well, it was kind of inferred today that, you know, don't grow these brassica crops in your rotation then as these brassica crops after them. And we're kind of seeing that same type of phenomena. And then it's just a question of what's more important. Is it the combination of both the winter and the summer, or is it the winter one that's more important, or is it the summer one that's more important? And then they may be different in terms of how the crop responds versus how the weed responds to it. And so trying to sort through some of those things, if you're struggling with something, we may say, use these as your rotational crop. It impacts your crop a little bit, but we could change our fertility because we can add fertility into these systems. We just chose not to. So I can up my fertility by doing something if I need to do that. But if I have a particular weed complex that I really want to attack, certain combinations might be better for that. Okay? Good. Thank you so much.